Settle in, everyone. Welcome. I want you to pay close attention because what you're about to see is probably the most important engineering briefing of your entire lives. We're not talking about next quarter's profits or a new product launch. We are talking about humanity's grand strategy for its own long-term survival. Let's get to it.
So let's just start with the most fundamental question of all, the one that's going to define every single thing we do from this day forward. What is our ultimate mandate?
It's this. Simple as it sounds, our job, our only job, is to ensure the long-term survival of humanity. Now, that is incredibly easy to say, but it is, without a doubt, the greatest engineering challenge ever conceived. Everything we do serves this one core objective.
So here's the roadmap. It's a 3-phase plan, and it's designed to take us from where we are right now to a future that's actually secure. We're going to start at home, then we'll make that critical leap into orbit, and finally, we'll build our new frontier up there.
Okay, phase 1. It begins right here, on the ground. Before we can seriously reach for the stars, we have to secure our foundation, and that means we have to identify and neutralize the biggest natural threats to civilization on this planet. Look, the data on this is crystal clear. Forget what you've seen in the movies about asteroids. The single greatest planetary risk we face is actually lurking right below our feet. The number you see here, 1 billion, that's the estimated number of lives at risk from just one supervolcano eruption. And we have about 20 of them active on Earth right now. We don't wait for disaster, we engineer our way out of it. So how do we do it? Well, this is the plan. And it comes from some of the sharpest minds at NASA. It's absolutely elegant. Instead of trying to fight that immense power, we siphon it off. We drill down around the magma chamber, we use water to literally pull the heat out, and in the process, we turn an existential threat into a massive, continuous source of clean, renewable geothermal energy. It's a total win-win. So, once our homeworld is a bit more secure, we can turn our attention to a threat that's, it's more subtle, but it's just as dangerous in the long run. This isn't about some big, sudden event. It's about a fundamental limit of physics that we are approaching way faster than you think. This chart, wow. This chart basically tells the story of our entire modern civilization, an absolutely explosive, exponential surge in energy use. We're talking a 7,000% increase that's fueled everything from modern medicine to the very screen you're watching this on. But this beautiful upward curve, it's on a collision course with reality. And this is the trap. This isn't about running out of energy, and it's not even just about carbon emissions. It's about basic thermodynamics. See, every single watt of energy we generate and use here on Earth ultimately ends up as waste heat. And as this quote explains, if we keep going, we're eventually going to start cooking the planet with our own heat, no matter what the energy source is.
So you see the problem, right? The laws of physics are basically pointing us in one direction, and one direction only. If we want to keep growing as a species, we simply cannot keep pumping this much energy into our planet's fragile system. The only real solution is to move our heavy industry and our massive power generation off-world, where all that waste heat can just radiate harmlessly away into the vacuum of space.
Which brings us to the most ambitious and, honestly, the most exciting part of this whole mission. Phase 3 isn't about fixing problems anymore. It's about building the future. It's about laying down the core infrastructure for a real, thriving, space-based economy. The first absolutely critical project is the space elevator. Think of it as the highway to the skies that makes everything else economically possible. Now, the biggest challenge here is a materials science one. We need to perfect carbon nanotube production for that 36,000-kilometer-long cable, but that is a defined engineering problem, not science fiction. And this number is the reason it's all worth it. Dropping launch costs to under $100 a kilogram, we're talking a reduction of over 50 times. It just changes the entire equation. All of a sudden, building giant solar power arrays, huge data centers, and manufacturing plants in orbit, it's not a fantasy anymore. It's just a logistics problem we can solve. So once that elevator is up and running, giving us cheap and easy access to orbit, we can start building the true centerpiece of our off-world infrastructure, the orbital ring. And this isn't just another space station. We're talking about the literal backbone for the next stage of human civilization. And what can this thing do? I mean, the capabilities are just staggering. We're talking about traveling from one side of the Earth to the other in under an hour. Entirely new industries built around microgravity, a platform to manage our climate. And yeah, Eventually, habitable zones with artificial gravity, the actual foundation for the very first cities in the sky. And I know what you're thinking, this must cost a quadrillion dollars, right? Well, get this. Preliminary studies put the cost for a prototype ring at around $9 billion. That is an entirely achievable number. That is well within our engineering and economic reach starting right now. So, that's the strategic vision. And this is where you come in. This is the moment we move from the theoretical, from the presentations, to the practical. We have the roadmap. We understand the threats here on Earth, and we understand the physical limits that are pushing us out into space. We have the technical designs for the infrastructure that's going to get us there. The planning phase is over. The mission now is all about execution. So, this is the challenge that we are laying at your feet. It is the greatest one humanity has ever faced, period. It's going to demand everything you have, your creativity, your discipline, your courage. So I'm going to ask you one last time. Engineers, are you ready to build the future?